Okay, this is part 2 of the study guide that you guys are to complete by Wednesday. So it was given to you on November 30th, Friday, November 30th. Let me just show you what the front looks like real quick. So it was the one that says Unit 2, even though we're in Unit 3, it's the one that says Unit 2. This was the first page. I did that on the part 1 of the video. Part 1 video, here's the part 2 video with the second page. Okay, quadrilateral MNQP. MNQP is made of two congruent triangles. NP bisects angle N and angle P. In the quadrilateral, the measure of angle N is 38 degrees and the measure of angle P is 104 degrees. What is the measure of angle Q? Okay, so we have quadrilateral MNQP. NP bisects angle N. So again, I don't like how they name the angle N. It should be angle MNQ. Right, because we don't really know what angle N is. Okay, and then they should have named angle P angle MPQ. Right, but they're talking about the whole thing here. Okay, so NP bisects, so NP, this line right here, bisects angle N or angle MNQ. Okay, it means it splits it in half. So it means these two pieces, angle MNP is going to be congruent to angle QNP. So it splits 38 in half. So the measure of angle N was 38. So the bisector splits it in half. It's into two congruent pieces. So 38 divided by 2 is going to be 19. So we have 19 and 19. These two angles are congruent. The bisector splits the angle in half. So we have 19 and 19. It also bisects angle P or angle MPQ. Okay, so it splits this angle in half, right? So we now have two congruent angles. Okay. So that angle was 104, right? 104. We split it in half, so 104 divided by 2 is going to be 52. So now we know we have 52 and 52. And the question is, what is the measure of angle Q? Well, we know three angles in a triangle add up. The measure of the three angles of a triangle add up to 180. So 52 plus 19 plus the measure of angle Q is going to be 180. 52 and 19 is 6171 plus the measure of angle Q minus 71 from both sides. The measure of angle Q is going to be 109 degrees. Okay. If it's easier for you to just do 180 minus 19 minus 52, that's fine. Either way would work. All right, so that's going to be minus 71. Okay, number 19 through 24. We want to determine which postulate we can use, if any, to show that the triangles are congruent. So number 19, we have angle ADB is congruent to angle CBD. Angle ABDB is congruent to angle CBD. We have AB is congruent to DC. Okay, and we know we can use a shared side. Okay. So again, let's think about the postulates we have. We have side, 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 angle, side, angle, 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 side, and hypotenuse leg. So three sides, three corresponding sides of two triangles are congruent, then the triangles are congruent. If we have two corresponding sides that are congruent and the included angle is congruent, then the triangles are congruent. If we have two corresponding angles that are congruent and the included side is congruent, then the triangles are congruent. And here we have, if two corresponding angles are congruent and a non-included side is congruent, then the triangles are congruent. And then a hypotenuse leg says if we have right triangles and the hypotenuses are congruent and one pair of legs is congruent, then the triangles are congruent. So here, let's cover one up. We have angle, side, or side angle. Is side angle one of our 5 postulates that prove triangles are congruent? It is not. We don't have any right angles, so we can't use hypotenuse leg. So there's nothing else we can do here. There is not enough information. And not enough information. Okay, number 20. Again, just like 19, we have a shared side, so we have reflexive property or symmetric, however you want to look at it. If AC is congruent to AC, that is the reflexive property. If AC is congruent to CA, that is the symmetric property. And again, we're looking for, in all of these, in these 4, side, side angle, side, angle, and angle, side, we are looking for 3 corresponding parts that are congruent. With hypotenuse leg, we're looking again for 3 things: right angles, hypotenuses that are congruent, and a pair of legs that is congruent. So in each case, we're looking for 3 things. So do we have 3 parts? We do. We have AB is congruent to DC. We have AC is congruent to AC by the reflexive property. And then they're also giving us that angle BAC is congruent to angle DCA. Okay. Cover up one of our triangles. Is this an angle or side? This is a side. This is an angle or side. That's an angle. And then is this an angle or side? It is a side. So we have side, angle, side. Side, angle, side, right? So we have 2 sides and the included angle. 2 sides and the included angle, the angle that is between them. So here's 2 sides and the included angle. Side, angle, side. Okay. Now they want the congruence statement. Congruence statement. So we pick one of our triangles, and there's 6 different ways we can name it. So let's just do ABC. ABC. Okay, so there's 6 different ways we can name the first one, but once we name the first one, there's only one way we can name the second one. There's only one correct answer that can go here. There's 6 different choices that can go here. Okay. But once you pick one, you have to match it up with the corresponding part of the next one. Okay, so if we start at A here, we have to start at C, right? If we flip this triangle around, okay, we take these triangles apart, and we rotate it all the way around. Okay, we're going to end up with something like this. Okay, this is going to be, right, C is being rotated up here. So C goes up there. Okay, D is getting rotated down here, right, and this becomes A. And our shared side is AC. Okay, and then AB is congruent there. So what corresponds with A in the first triangle is going to be C in the second triangle. What corresponds with B in the first triangle? Well, this is the first triangle. Okay, what corresponds with B is going to be D. Okay, we flipped our first triangle. So this is our first triangle. So what corresponds with A, it's going to be C. What corresponds with B, it's going to be D. And then what corresponds with C is going to be A. Okay. So we take our first triangle ABC, and we spin it around, flip it around, rotate it. Okay. So we have ABC. What corresponds with A is going to be C. What corresponds with B is going to be D. What corresponds with C is going to be A. Right. ABC is congruent to CDA. We could have written this one 5 other ways, as long as the second triangle matches the same order. Okay. Let me erase all this and let's do 21. So it says Z is the midpoint of WY. So Z is the midpoint. I'm seeing this now. They're giving us information for 19. So we're going to come back to 19 after we do 21. We'll do 21 and then go back to 19. So they're telling us Z is the midpoint. Okay, we have a midpoint. We know we have congruent segments. So WZ is congruent to YZ. We have a shared side. So how many corresponding parts do we have that are congruent? We have 3 corresponding parts that are congruent. So cover up one of the triangles and we have side, side, side. So by side, 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 we know triangle. Let's just do XYZ is congruent to triangle. What corresponds with X? It's going to be X. So what's between the 2 and the 3? It's going to be X again. So we go X, Y. So we got to go Y. I mean X, Y. So we got to go X, W. So X, Y, Z, X, W, Z. All right, imagine taking W, pulling it out of the page, and flipping it down. Right, like turning the page of a book, right, or a notebook, a notepad. Right, imagine this was a notepad. Take W, flip it straight down. So you have X, Y, Z, and then on top of that you have X, W, Z. So if we go back to 19, it's telling us we have parallel lines. So it's saying AB is parallel to CD. So if we have parallel lines, we know alternate interior angles are congruent. So angle ABD is congruent to angle CDB. So let me erase this, but if you can see it, here's our alternate interior angles. Since the lines are parallel, we know those alternate interior angles are congruent. AB is parallel to CD, so alternate interior angles are congruent. So angle CDB is congruent to angle ABD by the alternate interior angle theorem. If we have parallel lines, then the alternate interior angles are congruent. So we have alternate interior angles and the lines are parallel, so therefore they are congruent. Then here we have the reflexive property. So before, when we couldn't do it because we didn't have these angles, right? We didn't have these angles. So we had angle side side or side side angle, which doesn't work. But now, since we're using the given information, which I didn't notice this time around, we now can cover our triangle up and we can either do angle, side, angle, angle, side, angle. Okay, we can do angle, angle, side, or we can do side, angle, side. So with that given piece of information, we now have 4 corresponding parts that are congruent. And since we have 4 corresponding parts that are congruent, we have a lot more choices available to us. Right, so reflexive property, then alternate interior angles. So we can do angle, angle, side, angle, side, angle, side, angle, side. Okay, and in the congruent statement, again, if we rotate around, so take B, we're going to take B and pull it down. Take B and pull it down. Can you see that? Let me just adjust it here. Well, I'll do it over here. I'll do it small. Okay, so if we take B and pull it down, this becomes B. This is B over here in the corner that you can't see. A is down here, and D is up here, right? We're twisting this, rotating it down, right? So triangle, if we have BCD, so what corresponds with B? It's going to be D. So BC is going to be A, and then D is going to be B. Right, so BCD is congruent to triangle DAB. So BCD, DAB. BCD, DAB. Right, again, take it, flip it. BCD, B. BCD. So BCD. So DAB. Yeah. Okay. 19. Do these three, and then we have proofs after that. So if GF is congruent to, so they're telling us GF is congruent to BC. So we have three pieces. So they're telling us EG is congruent to BD, GF is congruent to BC. We should have lines over them. And then since EFG is a right angle and angle EFG is a right angle and angle DCB is a right angle, by the right angle theorem, we know all right angles are congruent. So there's three corresponding parts that are congruent. If we just look at one triangle, we have side, side, angle. And I erased them, but we noticed before side, side angle is not one of our 5 postulates that we are able to use to prove triangles congruent. But there is a right angle, so we should check out the hypotenuse leg theorem. Okay, again, the hypotenuse leg theorem, we need 3 things to be true. Okay, we need right triangles. Okay. We need hypotenuses congruent. And then we need legs congruent. Do we have right triangles? Yes, we do, because we have right angles. If we have right angles, we have right triangles. The definition of a right triangle is a triangle with a right angle. Are the hypotenuses congruent? Well, what are the hypotenuses? They're the sides that are across from the right angle. So yes, we do. EG is congruent to DB. Do we have a pair of legs that's congruent? Well, they're telling us GF is congruent to BC. So yes, we do. Again, right, a right triangle has a hypotenuse and 2 legs. Right, this one has a hypotenuse and 2 legs. We only need 1 pair of legs to be congruent, which we have. Therefore, we can use hypotenuse leg. Okay. So let me erase, redo. These should stay the same. But again, right, a right triangle, hypotenuse, leg, leg. So we need right triangles, we need hypotenuses to be congruent, and we need a pair of legs to be congruent. So here's our hypotenuses, they're congruent. Here's our legs, they're congruent, GF and BC. And we have right angles, so therefore we have right triangles. So by HL, the hypotenuse leg theorem, these 2 triangles are congruent. We have to name our 2 triangles. So EFG is congruent to triangle. So what corresponds with E? Right, it's going to be D. Right. So we went EF. So we went from, right, we went to F, which is a right angle. So we're going to C, which is a right angle. Then up to B was the same as going from F to G. So D, C, B. Again, if we rotate this around, right, rotating this one around, here's our right angle. G comes up here. Our right angle is at F. This is E. So EFG is congruent to DCB. EFG, DCB. EFG, DCB. Rotate it. Same. 23, we have shared sides. We know right angles are congruent by the right angle theorem. Okay, they're telling us angle DEC is congruent to angle BEC. Okay, so we have three corresponding parts that are congruent. So let's see if we can use one of our postulates. Cover up one of the triangles. This is an angle or a side. This is an angle. Angle or side, that's an angle. Angle or side, that's a side. So angle, angle, side, which is one of our postulates. So by the angle, angle, side theorem, we know the triangles are congruent. So triangle, we'll call it BCE. Let me write it down here. Triangle BCE is congruent to triangle. So B is the right angle. So it's going to correspond with D. Okay, so we're going from B to C. So in this case, B to C. I think this drawing is a little funky. All right, so if we went from B to C, right, we're going away from the other angle. So that means these two sides are going to have to be corresponding, right? So we're going to go from B to C. We have to go from D to C. Right? They just really weird drawing. It's not to scale at all based on what they have. Right, and then we went from C to E, so we also have to go from C to E. Okay. So B, C, E. So it's really a little off. Yeah, I don't like how that's drawn. That really bothers me. Right, D. So if we went D to C to E, then we'd have to go B to C to E. Just it's drawn not the way it really looks based on the information they give. Based on the fact that these two angles are the same, right? It does not look like this angle is smaller than this angle. Don't get confused by this problem. So I don't like this problem because I don't like the way it's drawn. We see how this looks smaller than this one? And so it looks like it should be DEC and BCE. How it's drawn, that's how it looks. It looks like these two angles are the same. But not on the way it's drawn. So don't worry too much about that one if you don't see it. What's up? I don't like that problem. I think I did that wrong in the other video. I think I got caught on by the visuals. Okay, well, TR is congruent to QR. So TR is congruent to QR. And we have vertical angles. So put our vertical angles in. And then we're going to have angle, side, angle. So here we have angle, side, angle. Right, we have three corresponding parts that are congruent, so we can use the angle, side, angle postulate to show that these two triangles are congruent. So we have triangle TRS is congruent to triangle. Again, TR, so QR, U. Okay, TRS, QRU. Sorry, I'm caught up on 23 still. Right, so if we were to rotate it, what we'd have to do is we have to flip it over this way. So here is triangle EDC. Right, we all see EDC. Okay, if we flip it over and then up, right, we should have, right, so this side's congruent, these angles are congruent, so these angles are congruent, that means these sides are congruent, and then these sides are congruent, and then these angles are congruent. Right, see how it visually doesn't make, so if we just looked at the sides, we can see it looks kind of odd. But clearly this side looks shorter than that side. But we have to go with what we're given, and that's what we're given. Okay. All right, anyways, that's the non-proofs. So now we have 6 proofs to complete. Okay, you will have a couple proofs on your test. You should be able to do proofs. Not as many as I would like, because I like proofs. All right, our process is to first write the givens. So let's first write our, let me zoom in. We'll do one at a time. Zoom in on each one. So we have 2 givens. L is the midpoint of JM, and JK is parallel to MN. So they've written those in. Okay. Next thing I like to do is to look for shared sides or vertical angles. We do have vertical angles. So angle JLK is going to be congruent to angle MLN, okay, by the vertical angle theorem. So again, this is a little bit out of order to how I would do it and how I taught you guys to do it, because I taught you guys to go in the same process. Write the givens, look for shared sides or vertical angles, and then use the givens. Okay, we can still do that though. So wrote the givens, so check, right? Wrote the givens, look for shared sides or vertical angles, check. Step 3 in the process is use the given. So let's use our midpoint. If we have a midpoint, we're looking for congruent segments. So L is the midpoint of JM. So L is the midpoint of JM. Okay, so here's JM. L is the midpoint. So a midpoint, the definition of a midpoint, right, is the point that splits the segment into 2 congruent segments. Okay, so L is going to split JM into 2 congruent segments. So JL is going to be congruent to ML by the definition of a midpoint. It splits, the midpoint L splits JM into 2 congruent segments. So JL is congruent to ML. Our second given we have is parallel lines. If we have parallel lines, we are looking for alternate interior angles. Okay, so we are looking for alternate interior angles. So alternate interior angle theorem. Okay, which says if the lines are parallel, then the alternate interior angles are congruent. So here we have 2 parallel lines. Here's our transversal. Okay, JKL is congruent to MNL. Okay. These are also would be congruent, but they're not part of this proof. But we could put them in if we didn't have a guide to follow. Okay. So let me erase the lines. Hopefully you guys could see the alternate interior angles here. Okay, we said those were congruent, and then we said our vertical angles were congruent as well. So let's go back. We've written the givens, so we write the givens. look for shared sides or vertical angles, and then we can use the given. So this would be step 1, step 2, step 3, step 4, step 5 if we were doing it our way. Write the givens, look for shared sides or vertical angles, use the givens. If we have a midpoint, we're looking for congruent segments. If we have parallel lines, we're looking for the alternate interior angle theorem. We're looking for alternate interior angles that are going to be congruent. Okay, we now have 3 corresponding parts that are congruent, which is how many we're looking for. Cover up one of the triangles. Angle or side, that's an angle. Angle, side. Okay, so we have angle, angle, side, which says if we have 2 pairs of congruent angles, and we do, angle K is congruent to angle N, or we called it angle JKL and angle MNL. Okay. Our second pair of congruent angles is angle JLK and angle MLN. So 2 pairs of congruent angles and then the non-included side. So JL is congruent to ML. So right, it's the non-included side, angle, angle, side. It's not between them, so it's the non-included. So we have angle, angle, side. So if we have those conditions, then the triangles are congruent. Number 25. Okay, the other guided proof we have. Again, here we have 2 givens. So our first step in writing the proof is to write our givens. Okay, so we have one given, which is that dA is parallel to YN. Our second is that dA is congruent to YN. So in our process, step 1, write the givens. Step 2, look for shared sides or vertical angles. Here they're showing shared sides. First, let's try to prove that the triangles are congruent. Okay, let's not prove the angles. Let's prove triangle NDY is congruent. So let's cross out this last step. Let's just focus on proving the triangles that are congruent. So DA is parallel to YN. Okay, and DA is congruent to YN. So we have both of those labeled in our diagram. The arrow indicates that these lines are parallel. The hash mark, the dash, represents that these 2 segments, DA and YN, are congruent. So step 1, write the given. Step 2, look for shared sides or vertical angles. We do have a shared side. Okay, DN. So DN is congruent to DN by the reflexive property of congruence. So step 1, write the givens. Good. Step 2, look for shared sides or vertical angles. Good. Step 3, use the givens. So right now we have 2 pairs of congruent, or 2 corresponding parts that are congruent. We need a third. Luckily, we have another given that's not a congruent statement. Okay. So let's look for, again, parallel lines. We're looking for alternate interior angles. Okay, here's our parallel lines. Here's the transversal, DN. So where are alternate interior angles? Right here. Angle YND is congruent to angle ADN. And again, a lot of you on the quiz and stuff were making the same mistakes where you were saying that these two angles were alternate interior angles, right? These two. Okay. These are alternate interior angles if we had these parallel lines, right? But there's nothing here that suggests that those are parallel lines. So therefore, we can't say that they're congruent. Okay. Right, those are alternate interior angles, but we don't know if they're congruent, right? Because the alternate interior angle theorem says if, right, again, and that's not a full description. The alternate interior angle theorem says if the lines are parallel, then alternate interior angles are congruent. So if the lines are parallel, and in this case, DA is parallel to YN, then the alternate interior angles are congruent. Okay, you now have 3 corresponding parts that are congruent. So we can look for a postulate to prove that the triangles are congruent. So if we cover one up, we have a side, an angle, and a side. So by side, angle, side, triangle NDY is congruent to triangle DNA. Right? NDY is congruent to triangle DNA. You can flip this around. Right? NDY is congruent to DNA. Okay. The last step here, we talked about this, but we didn't do any proofs with it. We talked about how corresponding parts of congruent triangles are congruent. So since we know the triangles are congruent, we're going to know that angle NDY, right, is now congruent to angle DNA. We know that's congruent by the corresponding parts of congruent triangles are congruent, CP, CTC. Okay, we talked about that principle, but we didn't do any proofs with it. So we really should just stop at step 5 here. Okay, you won't have this on the test. All right. Now we have the two open-ended ones, so we can fully use our process, right? Write the givens, look for shared sides or vertical angles, use the givens. Okay, for bisector, you're looking for congruent angles. If you have an angle bisector, you're looking for congruent angles. If you have a segment bisector, you're looking for congruent segments. If you have a midpoint, you're looking for congruent segments. If you have parallel lines, you're looking for alternate interior angles. If you have perpendicular lines, you're looking for right angles, and then either right triangles to do the hypotenuse leg theorem, or we can say right angles are congruent by the right angle theorem. I think that's all the ones you're going to have. Okay. So here, let's write steps, justifications, or reasons. Okay, step 1 is our givens. We have two givens. Angle Z is congruent to angle C, and AK bisects angle ZKC. That is given and given. So we have drawn in already. They have for us angle Z is congruent to angle C, and they have our second given here is AK bisects angle ZKC. So we've written the givens, step 2 in our process after we write the givens to look for shared sides of vertical angles. We do notice we have a shared side. AK is congruent to AK. Wait, remember our goal here is to look for 3 corresponding parts that are congruent. So we have AK is congruent to AK by the reflexive property of congruence. Okay. So far we have 2. So write the givens. Right, that gave us 1. We looked for shared sides of vertical angles. That gave us a second corresponding part that was congruent. Third step in the process is to use the givens. And we're going to use the givens to get our third corresponding part. So we have an angle bisector. We are AK, segment AK. If we made it line AK, it would look like that. But AK is bisecting angle ZKC. So this is ZKC. So we are bisecting this angle, meaning we are splitting it into 2 congruent angles. We are splitting it in half. We're splitting angle ZKC into half. We are bisecting AK right here. This is AK. You guys struggle with the bisectors on the quiz more than anything else. AK bisects angle ZKC. So we are splitting this angle in half. Okay, we are bisecting it. Definition of an angle bisector is a line, segment, or something that bisects the angle. It splits the angle into 2 congruent angles. So angle ZKC is bisected. ZKC is bisected and split into 2 congruent angles. Angle ZKA is going to be congruent to angle CKA by the definition of an angle bisector. So we wrote the givens. We look for shared sides of vertical angles. Then we used our givens. We now have 3 corresponding parts that are congruent. So let's cover up one of our triangles. Angular side, that's an angle. Angular side, that's an angle. Angular side, that's a side. So by angle, angle side, we know that triangle, all right, this is what we're trying to prove. All right, triangle AKZ is congruent to triangle AKC. We have two angles that are congruent and a non-included side. So we have two angles that are congruent. Right, one angle, two angles, and the non-included side, the side that's not in between them. Angle side. Number 28. So again, two givens. Okay. One given, two. So we know that triangle QRS is isosceles with QR being congruent to SR. So QR is congruent to SR. And the other given is that RT bisects QS. So this time it's a segment bisector. We're bisecting segment QS. And it bisects it at point T. So two givens. Okay, so we've written our givens. Next thing we should do is look for shared sides of vertical angles. We do have a shared side. So TR is congruent to TR by the reflexive property of congruence. Okay, if you want to say TR is congruent to RT by the symmetric property, that's fine with me. Write our givens, look for shared sides of vertical angles, use our givens. So again, the first given they have us ends up with a congruent segment. Right? It's because we have an isosceles triangle, we have QR is congruent to SR. And then by a reflexive property, we had a congruent segment. So our other given that we haven't used that doesn't have a congruent statement is 2, that RT bisects QS at point T. Okay, so RT, right here, bisects QS at point T. Okay, so bisects QS means it cuts it in half. So we are cutting QS into half, into two congruent segments. So QT is going to be congruent to ST. Okay, and that is the definition of a segment bisector. Definition of a bisector would be fine. Definition of segment bisector, definition of bisector. We now have three corresponding parts that are congruent. Cover one of the triangles, side or angle, that's a side, that's a side, that's a side. So we're going to use the side, side, side postulate, which tells us if we have three corresponding sides that are congruent, then the triangles are going to be congruent. So triangle QRT is congruent to triangle SRT. Okay. QRT is congruent to triangle SRT by the side, side, side postulate. So write your givens, look for shared sides of vertical angles, use the given. Then we have three pieces, cover one of the triangles, and we see that we have side, 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 which is one of our postulates that works. So we're good to go. Two more. $29. $29 or $2 for $50, right? Saves you $8. 29 or 2 for 50. Okay. This one's pretty blurry. Well, I think yours is, you can see it a lot better than I can. We're already at 45 minutes. Wow. Okay. So AB is equal to CD, which means that AB is congruent to CD. So steps, justification. Okay, 1, we're just going to say AB is congruent to CD. And then 2, AB is parallel to CD. So AB is congruent to CD, indicated by this hash mark. And then we have an arrow representing or telling us that AB is parallel to CD. So we've written our givens. Step 2 in the process after we write our givens is look for shared sides of vertical angles. So we have shared side. AD is congruent to AD. That is the reflexive property of congruence. Again, we could have done AD is congruent to DA by the symmetric property. It's fine. Okay, so step 1. So right now we have 2 corresponding parts that are congruent. We need a third. Okay. Step 1, write the givens. Step 2, look for shared sides of vertical angles. Step 3, use the givens. So the given that does not have a congruent statement already in it is that AB is parallel to CD. So just like we've done time and time again, if we have parallel lines, we're looking for alternate interior angles. So here's our parallel lines. Here's our transversal. Right, this is our transversal. So where's the alternate interior angles? Right here. Angle BAD is congruent to angle CDA. Right? In the alternate interior angle theorem states, I can't talk and read at the same time. So just, right, the alternate interior angle theorem states that if the lines are parallel, which they are, then the alternate interior angles are going to be congruent. Again, not these angles. We don't know that AC is parallel to BD. So we have to do the alternate interior angles with respect to the 2 parallel lines. Okay, let me erase the lines. Right, hopefully, again, you guys are able to see those alternate interior angles. So again, we have reflexive, we have given, and now we have alternate interior angles. So we now have 3 corresponding parts that are congruent. So let's see if we can prove that triangle ACD is congruent to triangle CAB. Right, you should write that first before that. But cover one of the triangles. Side or angle, that's a side. That's an angle. That's a side. Right, cover one of the triangles. We have side, angle, side. Two sides are congruent and the included angle. Okay. 30. Okay. 30. So write our givens, step 1, write our givens. We again have, well, we have 3 givens now. 1, 2, 3. So CD bisects AE. Okay, we have AB parallel to CD. And then we have angle E is congruent to angle BC. Angle E is congruent to angle BCA. Given. Okay. CD bisects AE. AB is parallel to CD. That's our arrows. And then angle E is congruent to angle BCA. So angle E is congruent to angle BCA. Okay. Step 1, write the givens. We have that. Step 2, look for shared sides of vertical angles. We do not have any shared sides or vertical angles in this case. So let's go to step 3, which is use our givens. So let's just go in order. Use the first one. CD bisects AE. So CD bisects AE. So it cuts AE in half. It splits it into 2 congruent pieces. It bisects it. It splits it in half. It splits it into 2 congruent segments. So we have a segment AE and a bisector. CD splits AE into 2 congruent segments. So those congruent segments are AC and CE. Again, definition, bisector is fine. Segment bisector is better. Bisector is fine. Let's use our next given. We now, again, got a congruent piece out of it. So we're now at 2. We got to use our other given now to get a third. So AB is parallel to, let me erase all this just so we can see this. So AB is parallel to CD. So when we have parallel lines, in almost all cases, we're looking for alternate interior angles. In this case, we're not. In this case, we're going to have corresponding angles. Okay, so angle BAC is going to be congruent to angle DCE. Okay, and that's the corresponding angle theorem. Getting tired, so I'm writing slap here. So parallel lines, here's our transversal. These are corresponding angles. The corresponding angle theorem says if the lines are parallel, then the resulting corresponding angles are congruent. So here we had given, okay, definition of bisector, corresponding angle theorem. We now have 3 congruent pieces. Okay, let's see what we have. Cover one triangle up. Angular side, that's an angle. Angular side, that's a side. Angular side, that is an angle side angle, which is one of our postulates that tells us if we have 2 pairs of congruent angles that are congruent, 2 corresponding angles that are congruent, then and an included side that's congruent, then by the angle side angle theorem, triangle ABC is going to be congruent to triangle CDE. Okay, so that's the end of part 2 of the review. There will be some proofs on the test, so follow the process. Write the givens, look for shared sides or vertical angles, use the givens, and you should result with 3 corresponding parts that are congruent, and then cover one of the triangles up and see what order they are in. And use that postulate to prove that the triangles are congruent. Okay. So that's the end of the Unit 3 review. So I have 5 videos now for 4 different assignments, review assignments. So if you can do all 4 of those assignments, everything on there, you should easily get 100% on the exam.